Alright guys, so this video goes with 3.5. 3.5 is operations with matrices. So when we work with matrices, we're going to be working with addition, subtraction, and multiplication. Now, instead of doing division with matrices, we would do what's called working with the inverse. So if I do, instead of 4 divided by 2, I can do 4 times 1 over 2. So the inverse of 2 is 1 over 2. And then we would just multiply together, and 4 times 1 over 2 is the same thing as 4 divided by 2. So instead of division with matrices, we would be working with inverses and then multiplying that. All right, so let's go through our basic operations. So first we have on the screen is you have the rules. To add or subtract matrices, dimensions must be the same. So what that means is, first, let's talk about what a dimension is. So the dimensions are the rows, and then you say the columns. And it's the number that is involved. So if I have these two matrices, the matrix on the left, right here, that is considered a 2 by 2 matrix because there are 2 rows, row 1, row 2, and 2 columns, column 1, column 2. So this is a 2 by 2. The right matrix is also a 2 by 2. Because the left matrix is a 2 by 2 and the right matrix is a 2 by 2, you can add them together and you are going to end up with the same dimensions, a 2 by 2. To add or subtract matrices, again, the dimensions have to be the same because you work with the same component. So as in the top left of matrix 2, or matrix 1, 2, and then the top left of the matrix on the right 1, you add them together because that's the operator in between. So 2 plus 1 is 3. Then you do the top right. Top right of the left one is 4. Top right of the right one is 6. 4 plus 6 is 10. Bottom left of the left one is 3. Bottom left of the right one is 7. 3 plus 7 is 10. And then bottom right 5 plus the bottom right 8. That is 13. And then that just means that that's it. That's my answer. Now, again, you always check that the dimensions are the same. So if I have this one, we're not putting a comma. So in matrices, it's just that array of a rectangular or a square base of numbers. You do not separate the numbers by plus or on the inside with like a comma or a parentheses. You just put the number. That's why you need to make sure you leave space. That way I don't think that this right here is a 32. It needs to be a 3 and then a 2. So this one right here, if I list my dimensions, it's again rows and then columns. The left one has 2 rows and 1 column, so it is a 2 by 1. The matrix on the right has 1 row, 2 columns, so it is a 1 by 2. These dimensions are not the same, so I cannot subtract or add these. To add or subtract, it is not possible. So for this situation, you would check the directions. If it says write not possible, if you can't do it, then make sure you are writing not possible. Now, I do want to briefly mention, we're not going to do this in 3.5, it will be in 3.6, is that you can multiply this one right here. So if this symbol was not here and you were multiplying, you can actually do this. The rule for multiplying, and again, we're going to cover this in 3.6, so if it's confusing right now, we're going to clarify it in the next video, is the number of columns on the left must equal the number of rows on the right. So again, columns, rows. If those two numbers are the same, then we're good to go. You would end up with a 2 by 2. So this kind of pattern that I just drew is, again, following the rule of the number of columns on the left must equal the number of rows on the right. And then the dimensions, when you list them, the outer 2 numbers will actually tell you the result of when you get done multiplying, what your new dimensions will be. So if I multiply a 2 by 1 and a 1 by 2, again, I can do that. I'm going to end up with an answer that is a 2 by 2. And again, right now we haven't gotten to this yet, so we don't know the pattern. You may be wondering how in the world are we going to get that, and that's okay. We'll explain it in the next video, and then once we find the pattern, it will make more sense. Okay, so let's practice another one with a different dimension. we have this. Again, for subtracting, again, make sure that you are checking the sign in between to make sure you're using the right operator. We are subtracting, which means the dimensions must be the same. On the left, we have 2 rows, 3 columns, so it's a 2 by 3. On the right, it is also 2 rows, 3 columns. It is a 2 by 3. Let's double check to make sure that we're on the right track. Rows are what goes left to right. Columns are the things that go up and down. If you've seen in school, there are some rooms that have columns in the middle of the room, or columns maybe against the wall that you see. It's those like rectangular things that go from the floor to the wall. That is a column. So the columns, again, go from the floor to the wall, which is up and down. All right, so this problem, it is the same dimensions. So all you're going to do is, again, my answer is going to be the same dimensions. To get my new top left, right, so this spot right here, you're going to take this top left, so top left, minus this top left. So 5 minus 2, 5 minus 2 is 3, top left. Then top middle, 3 minus 0 is 3. And then top right, 3 minus negative 3. Again, that's a minus negative, so make sure you add. 2 plus 3 is 5. Then bottom left, negative 4 minus 5, that is a negative 9. Bottom middle, 6 minus 1 is 5. And bottom right, negative 7 minus 2 is negative 9. And that's it. That's your answer. Adding and subtracting, again, that's all you're doing. So you know how to add, you know how to subtract. It's just making sure that, one, you watch the signs, make sure that you're actually looking at a negative, versus a positive, so on and so forth. But then making sure you do put it in the right position. Now, we're also going to talk about what's called a scalar. You have actually worked with a scalar before. When we did systems of equations and we did elimination, we may have had to multiply one of the equations by a number in order to eliminate that said variable. But what you would do is you would distribute that number to all 3 numbers. So like an example, if we needed to get rid of the y, but we needed to multiply it by 2, you use distributive property to turn it into this statement right here. This right here, that 2, that is considered a scalar. It's what you're using to multiply the whole thing by, or to scale the whole thing. So we scaled that equation, 3x minus 2y is equal to 5 by 2. So again, that scalar factor was 2. So we can also scale matrices. What that looks like if we scale matrices is you would have a number right outside. And again, if you don't see anything in between a number and a matrix, right, nothing right there, that means that you are multiplying. Now, do not put the scalar in brackets. So do not do this. Because if you do that, it looks like you're multiplying a matrix of 3, which is just a 1 by 1 matrix, by the matrix on the right, which is a 2 by 2. And you can't do that. So if it is a scalar, do not put it in brackets. Make sure you do watch the operators because, again, it's not the 3 is not a matrix. So all you're going to do is, again, scalar, just like we did distributive property. You just apply the distributive property. So multiply all 4 numbers that you have in this matrix by 3. Do not change the position, so do not change where they are. So as in the top left, 3 times 1 is 3. Top right, 3 times 2 is 6. Bottom left, 3 times 3 is 9. And bottom right, 3 times 4 is 12. And that's it. You just scaled it. You multiplied everything by 3. All right. You can also combine all the pieces together. So if I have 4, so if I have 4 times this matrix minus 5 times this matrix, you're going to scale and then do the math. Now for this problem, you actually have 2 options. So let me write them out. Option 1, and it's more for the right way. So for that negative 5 matrix, you can multiply or scale. Let's do scale. So scale by -5, and then you will add your matrices. Option 2, scale by just a +5, and then you will subtract your matrices. What I'm going to do is I'm going to work out both of them real quick. Sorry, matrices. So I'm going to work them both out real quick. That way you can see the differences. So we're going to start with option 1 here, and we'll do option 2 here. Okay, so option 1, again, just 1. You're going to do the first one on the left. So multiply everything on the left matrix by 4. So that's going to turn it into a 12, an 8, a 4, a 0. Because again, all I did was multiply all 4 numbers by 4. So option 1, we're going to scale by -5 and then add the matrices. Because if you need to, that's the same thing as a plus -5 or just a -5. So I'm going to add the matrices, and I'm going to multiply everything by -5. So -5, -15, -10, and -20. And then option 1, I can continue. They're both 2 by 2s. I can add together. So 12 plus -5 is 7. 4 plus -15 is -11. 8 plus -10 is -2. And 20 plus, 0 plus -20 is -20. So you have this for option 1. Option 2, you're going to do the same thing. Nothing impacts how we would scale the matrix on the left, so that stays. But now this time we're going to scale by 5, but we're going to subtract. So just use the 5. So 5, 15, 10, 20. And then now you subtract. 12 minus 5 is 7. 8 minus 10 is -2. 4 minus 15 is -11. And 0 minus 20 is -20. If you notice, again, I used 2 methods, but the answer is the same. Because plus -5 is the same thing as just subtracting 5. So you can use either option. This is it for 3.5. So 3.5 is scaling, adding, subtracting, working with the operators, and then knowing when something is not possible. The other thing is, if you know it's not possible, don't do the work, right? Check the dimensions, see if you can even do it. If you can't do it, mark it, move on, get to the next one. All right, so that is it for 3.5. Make sure that you ask me questions if you have any. All right, thanks, guys.